Today on The Philosopher's Zone, a special guest on some unfinished business.
We're a very strange species in many ways, and the language capacity seems to be at the root of a good deal of this uniqueness. From 25 or 30 sounds that have no relation to anything in our minds, we are somehow capable of producing an infinite number of thoughts that express anything that we can imagine, and all, as they put it, all the movements of our soul, anything that's happening in our mental life.
It's okay.
What are words worth? Well, they are worth thinking about. And that's what Noam Chomsky has spent a lifetime doing. He's held firm to his theory of hardwired grammar, even though it's tricky to prove. And he doesn't buy the story that language emerged because we had to talk to each other to get things done. Simply, this is not where words came from. But rather, for an adequate explanation, we need to look inward rather than outward. And that's not so easy. Today, Noam Chomsky on the hard questions of mind and language. Professor Chomsky, welcome to The Philosopher's Zone.
Very glad to be with you.
Now, you've penned an elegant little summary of the hard questions that still confront us. I notice that language is still in the middle of it. Why is language such a difficult nut to crack?
We can start with what you might call the Galilean challenge. In the earliest days of the scientific revolution, Galileo and other great scientists and philosophers of the day were intrigued, in fact awed, by the fact that, as I'm paraphrasing, as they put it, from 25 or 30 sounds that have no relation to anything in our minds, we are somehow capable of producing an infinite number of thoughts that express anything that we can imagine, and all, as they put it, all the movements of our soul, anything that's happening in our mental life. And how is this amazing achievement possible? Galileo regarded it as the greatest invention in human history, greater than the achievements of Michelangelo or Raphael or Titian and so on. So the Galilean challenge is to try to answer the question, first of all, what mechanism of mind-brain makes this possible? How did it evolve? What's its nature? And so on. It wasn't really until the mid-20th century that tools became available, intellectual tools, for one to be able to at least formulate clearly some crucial elements of the problem and to address them and to identify the parts of Galileo's challenge that we can make progress with and other parts that remain total mysteries. Complete mysteries, no conception of how to progress with them.
Yeah, just with the way language has been viewed in recent times, that it is actually something to do with communication as opposed to other functions. Yeah. Where do you think that leads us? Do you think that evolutionary notion that we had to communicate because we had to cooperate and hence we have the language that we have now? How do you see that?
Well, there is a modern doctrine believed overwhelmingly that in some sense the essential nature and function of language is as a means of communication. But there's mounting evidence that that's just false, that language is primarily an instrument of thought, and it's mostly internal to our minds. In fact, we all more or less know that intuitively. You can't go 5 seconds without thinking to yourself in language. It takes an amazing act of will to prevent it, and by now there's even considerable evidence that a good deal of the internal use of language is unconscious and probably inaccessible to consciousness. But the empirical evidence that is increasing indicates that the externalization of language to some sensory motor system to articulation, which is the usual one, not the only one, that this is kind of peripheral to the core nature of language, which remains an instrument for, pretty much as Galileo and his colleagues believed, an instrument for the creation and expression, mostly internal expression of thought, instrument of thinking. And that means that communication is even more peripheral. It's, of course, true that we communicate with language, but we communicate with just about everything we do, with gestures, with style of clothes, with how you comb your hair, and so on. And language is, of course, a very rich means of communication, and we do use language for communication, but it's not its primary use, or it's by any means, and it's nothing like the essential function.
Mm. It sort of turns Aristotle's saying on this on its head, that it's not sound with meaning, but meaning with sound.
That's correct. I think that's a better way of looking at it. It's meaning usually with sound, but really that's only for convenience.
The acquisition of language, would that have been, you say that it's actually quite an abrupt and recent event, which to a large degree goes against the evolutionary story of adaptation over time.
Well, actually, that's a common misinterpretation of the theory of evolution. There are many well-known events by now in evolution that were sudden and radical changes. So, for example, the what's called symbiosis, the creation of what are called eukaryotic cells, the cells that constitute all complex organisms, apparently happened once with one bacteria kind of ingesting another. And out of that, structural constraints were broken and a whole range of enormous consequences developed. So the idea that it might have happened very suddenly doesn't break at all with evolutionary theory. It's a question of fact. And the facts just do seem to indicate that. We have limited empirical evidence about the timing of appearance of language, but what there is highly suggestive. So, for example, recent work on genomic work demonstrates that a particular group, San group so-called, in Africa, separated from the rest of Homo sapiens probably around 120,000 years ago. Well, as far as we know, they have the same language capacity, same cognitive system generally, which means that the origin of language must be prior to that, and furthermore, it has not evolved since. As far as we know, there are no group differences among humans in language capacity, or in fact in general cognitive capacity. So it emerged before roughly 120,000 years ago and has not evolved since. Well, Homo sapiens is only 200,000 years ago. So in evolutionary time, there's a tiny window in which this system emerged. Furthermore, it is increasingly clear that the language capacity is a true species capacity, not only common to humans, but also unique to humans. There's nothing remotely analogous elsewhere in the animal world. It's very rare in the whole biological world, and there's nothing similar in animals as far as we know. We're a very strange species in many ways, and the language capacity seems to be at the root of a good deal of this uniqueness. And it does appear to have originated in a very brief period. That raises a question of what happened.
That was going to be my next question.
Well, that's Galileo's challenge. And there are several aspects to what happened. Some of them we can get a grasp of and investigate and make real progress on. Others remain quite mysterious. So there are basically three questions. One is, what's the nature of the combinatorial system, so-called generative system, that yields an infinite array of structured expressions, each of which expresses a thought with a finite base? What's the nature of that system? That's one question. That's the one that we can make real progress on. Another question is, any combinatorial system begins with certain atoms, things that are unanalyzable from the point of view of the combinatorial system, like basically word-like elements that have meaning, words like river, tree, house, person, so on and so forth. Now, these pose an enormous mystery. They're completely unlike anything known in animal systems. We have no idea how they evolved, when they evolved, where they came from. They're common to all humans. They have very complex meanings. There's a kind of a belief, which is false, that the simple words like this just pick out things in the world. So you have kind of classic books called Word and Object or Word and Thing and so on. But that doctrine is just unacceptable. The words of language, unlike animal symbols, don't pick out extra mental objects. That's critical. We know that, there's good reason to believe it's true, but we don't know how it works. And as far as their evolutionary history is concerned, it's a complete blank. Not only is nothing known about it, but it's hard to imagine even how you could investigate it. We obviously don't have tape recordings from 200,000 years ago, and there aren't any other known avenues to inquire. Comparative work with other primates or even any other organisms just doesn't get you anywhere because they don't have these systems. That's the second question. The third question, which is actually the one that was salient for Galileo, for Descartes, and in the parts of the tradition that at least faced the challenge, is how we can use language in the innovative, creative way that we do. To put it in Cartesian terms, we are incited or inclined to say particular things, but not compelled to do so. So, for example, right at this minute, I could start talking about the weather outside,
yes.
Or, a baseball game that I saw 50 years ago, or a million other things. But I'm incited or inclined to give the kind of discussion that we're entering into. Actually, and here we have a total mystery, not just for language, but for voluntary action altogether. There's an interesting recent review of the state of the art in the study of voluntary action by two very leading neuroscientists, Emilio Bizzi and Robert Ajemian, and they discuss what is understood, and they end up by pointing out, rather, as they put it fancifully, that we're beginning to understand something about the puppet and the strings, but we have no idea whatsoever about the puppeteer. What makes it happen? That's a total mystery.
Noam Chomsky on those hard questions, today on The Philosopher's Zone. To that question of some things remaining mysteries, one of the things you write about in What Kind of Creatures Are We is that some things will just remain mysteries, and that is just a truism. And it's because we are, I guess, biologically caught in our form and in our shape and in what we're able to actually perceive.
Yeah, we're assuming that we're organic creatures and not angels. We have certain fixed capacities which yield the range of abilities that we have, but they impose limits as well. That's true of all of biological nature. So, for example, our genome, human genome, directs us to develop arms and legs, not wings, a mammalian visual system, not an insect visual system, that gives us scope, enormous scope, but also by the very logic of the situation imposes limits. And there's no reason to doubt that that's also true of our cognitive capacities. They give us enormous scope, but the very mechanisms that provide the scope also determine certain limits. And it's just an empirical question whether the kinds of things we would like to understand fall within the limits of the cognitive capacities that we are endowed with and that provide us with the remarkable abilities that we have. So the fact that there are limits shouldn't be regarded as a kind of a deficiency. It's just as the fact that we can't grow wings is not a deficiency. It's because we can grow arms. And the same is true in the cognitive domain.
And does this lead and attach to the question of the hard problem of consciousness?
Well, what's called the hard problem of consciousness. Actually, if you look through history, there were other hard problems. So in the 17th century, the hard problem was motion. And that problem is one that really was not settled within the framework of intelligibility that animated modern science. From the point of view of Galileo through Newton, that problem remains a total mystery. There's interesting things to say about that. Consciousness is a problem. In my own view, unconscious, what is inaccessible to consciousness, but enters directly into the fragments that reach consciousness, is probably even a greater and I suspect harder problem.
Can you elaborate on that? What does that mean?
Well, for example, take language, which we understand better than many other aspects of cognition. So when you do what we call talking to ourselves, when we think in language, what actually happens, if you think about it, is that bits and pieces and fragments come to mind, and you can sometimes put them together into a meaningful, complex sentence. But something's going on unconsciously which created all of this, generated it all, and we can't penetrate by introspection into what that is. Actually, that should no longer really surprise us very much. There are, for the last about 30 years ago, there was experimental work, the famous Libet experiments, which showed that, again, for simple voluntary action, like, say, lifting your finger, it turns out that a couple hundred, I think maybe 500 milliseconds before, maybe 300 milliseconds before you make the conscious decision to do it, there's already activity going on in the relevant parts of the brain, which there's been much discussion about what this means, but what I suspect it means is that the decisions are being made unconsciously and inaccessible to consciousness, though they then sometimes, not always, reach consciousness, and then we may implement the decision or choose not to. It seems very likely that in the case of the creation of thinking, which is basically what language is about, that same thing is happening. And I think there's pretty good evidence for it, just for the reasons I mentioned, that the very acts that you and I are now performing do rely on computational processes which we have some grasp of now from the outside, the way you study the laws of motion. We know them from the outside, but they seem to be going on the inside, and they're entering critically into what I'm producing and what you're interpreting, but we can find out nothing about them by introspection. In fact, if we could introspect into them, the study of language would be really easy. We would just think about it and, oh yes, all these principles would come out. They don't. And in fact, the principles are pretty surprising when you look at them.
And is this why it looks like it's an act of radical emergence to have mind from body or mind from material or mind from brain?
Yeah, but I think since the 17th century, we should really formulate the matter differently. There was a classical approach to body-mind. It's clearest, perhaps, in Descartes. And it was straight science. It wasn't nothing mystical about it. It's a straight scientific approach. Descartes. We have to begin with the conception of natural science that was held in the early modern period, say Galileo through Newton. The idea was that the world is a machine. And by machine, they mean things that push and pull each other, gears and levers, just a more complicated version of the fascinating automata that were literally being constructed by great artisans at the time. The world was that kind of machine, and in fact created by a super-skilled mechanic. It's called the mechanical philosophy. Philosophy just meant science, so mechanical science. The Cartesian dualism, body-mind dualism, was based on that principle. Descartes believed that he had given, at least in outline, an account of the machine. And his account was supposed to have dealt with the entire inorganic world, the entire non-human world, and a large part of the specifically human world, like perception, up to sensation and perception, for example. But he noticed that there were certain things that could not be accounted for in these terms. A crucial one was the creative use of language that I mentioned. That's what he brings up in the discourse. And that, as he recognized, simply lay beyond the capacity of any machine. That is correct. But what happened is that Newton, in the Principia, demonstrated that Descartes' system simply doesn't work, and in fact went beyond and showed that there are no machines. That's his invocation of a principle of action at a distance, which was central to Newtonian physics, could not be implemented in mechanical terms. Now, Newton himself regarded this as a total absurdity. He said no person of any scientific understanding can believe this, because, of course, it can't be true. And in fact, he spent the rest of his life trying to find some way out of this conclusion. He failed. Later generations also tried, but pretty much it was kind of given up over time. And the whole approach to science changed in a subtle way. Instead of seeking to show that the world is intelligible to us, the goals of science were implicitly lowered to trying to construct theories that are intelligible to us. So, for example, the recent discovery of the demonstration that Einstein was correct in predicting gravitational waves, that theory is intelligible to us. But the conception on which it is based of curved space-time, the quantum principles involved, for Galileo, through Newton and Hume and Locke and so on, that would have just been outside the framework of science, because it's not intelligible to our conceptual systems, which is their goal of intelligibility. So we can understand the theories, but they are intelligible, but the world isn't, and it's not a machine. Well, with that development, Descartes' mind-body problem disappeared. Not because there's any problem with mind, but because there's no body. If there's no body, there's no machine, there can't be a mind-body problem. Yes. And this was pretty much recognized. So, for example, John Locke, immediately after Newton, in fact, having read Newton's work, concluded that just as attraction and repulsion, the properties of motion, are unintelligible to us, but are nevertheless true, as the judicious Mr. Newton has demonstrated, he went on to say in the theological idiom of the time that just as God endowed matter with properties that are unintelligible to us, inconceivable to us, so God may have superadded to matter the capacity of thought, meaning thought is a property of some organic structure of whatever the world consists of. And that concept was pursued extensively through the 18th century, culminating finally in the work of Joseph Priestley, famous chemist, philosopher, late 18th century. It leads us to the scientific study of what properties of organized matter yield thought. And that brings you to the modern cognitive sciences and study of language and so on in today's conception. So it's not we can call it mind if we like, but that just means it's an aspect of matter, just as electrical properties are an aspect of matter.
Well, that pretty much brings it up to date, and I think that's where we'll leave it. I know you're a very busy man, Professor Chomsky. Thank you for being on the Philosopher's Zone. I suppose the provisional answer to what kind of creatures are we is that we're rather mysterious.
We are very mysterious, at least to ourselves. Maybe somebody else understands.
Thanks very much.
Thank you.
Professor Noam Chomsky, on what kind of creatures we might be. See you next time on The Philosopher's Zone.